Hi, welcome everyone to part 5 of my video playlist about the best methods to convert primary alcohols into alkyl chlorides. This presentation is about the use of iminium chlorides as deoxychlorinating reagents. These cationic reagents may be formed stoichiometrically or in catalytic quantities only, for instance when DMF is used to catalyze the formation of acyl chlorides. Iminium chlorides can be prepared from amides or ureas by treatment with a number of deoxychlorinating reagents, such as phosphorus chlorides, phosgene, thionyl chloride, or sulfonyl chlorides, but usually not with hydrogen chloride. Alcohols are converted by these iminium chlorides into alkoxyiminium chlorides, which are highly electrophilic and can react with even weak nucleophiles, such as chloride. Because alkoxyiminium chlorides are cationic, these intermediates show a different, often higher reactivity than for instance the neutral chloroformates or chlorosulfinates formed from alcohols by treatment with phosgene and thionyl chloride. During the formation of the alkyl chloride, the starting amide or urea is regenerated, what enables the use of such amides or ureas as catalysts. This is one of those few examples where phosphorus trichloride was used successfully as deoxychlorinating reagent. To prevent the formation of alkyl phosphides, phosphorus trichloride was first allowed to react with DMF for 40 minutes before addition of the alcohol. Here, phosphorus oxychloride instead of phosphorus trichloride was used to generate an iminium chloride from DMF. And the deoxychlorination of 2-octanol proceeded smoothly at room temperature. Without DMF, probably only trioctyl phosphate would be formed under such mild reaction conditions. Cyanuric chloride can also be used to convert amides into iminium chlorides. Here the activation of DMF was done without any solvent, but for larger scale preparations some inert solvent or a larger excess of DMF would probably be required to better control the exothermicity of the iminium chloride formation. In this instance, the deoxychlorination of the alcohol was conducted in the presence of sodium bicarbonate as base to prevent acid-mediated cleavage of the terz-butyl carbamate. This example shows how 6-acetyl-sucralose can be prepared from 6-acetyl-sucrose. The required iminium chloride was generated from an excess of phosgene and DMF. Interestingly, only the 2 primary hydroxyl groups and 1 secondary hydroxyl group were converted into chlorides, while 4 additional unprotected secondary hydroxyl groups remained unchanged. No bases were added, and despite the high reaction temperature, no cleavage of the acetyl groups occurred. Carbohydrate-derived acetyls are more acid-resistant than other acetyls, because the corresponding carbocations are destabilized by the vicinal, electron-deficient CO sigma bonds. Now, what are the potential side reactions? Iminium chlorides can also be used to dehydrate a number of other functional groups. Formamides of primary amines, for instance, can be converted into isonitriles by treatment with thionyl chloride and DMF, as described in this procedure from organic synthesis. If deoxychlorinating reagents such as phosgene or cyanuric chloride are added to a mixture of an amide and the alcohol may react faster with the activating reagent than the amide, and mixtures of products can result. Therefore, in many of the reported examples, the alcohol was added to a preformed mixture of the activating reagent and the amide. Iminium salts are highly electrophilic and can react with a number of nucleophiles, for instance with enolysed aldehydes or ketones, or with electron-rich arenes and heteroarenes, in the so-called Wiltzmeier reaction. In this example, acetylferrocene was formulated and deoxychlorinated by the iminium salt formed from phosphorus oxychloride and DMF. Here are a few more examples, but many more have been reported. The second reference is an example of the conversion of NMP into an iminium chloride by treatment with arene sulfonyl chlorides. The latter can, however, sometimes also be used to convert aliphatic alcohols into chlorides directly, without intermediate iminium chloride formation. This is the subject of the next video of this playlist.